Welcome to Daily Longevity RX. You tuned into the deep dive where we take your curiosity, your sources, and our expertise and distill it all down to the most important nuggets of knowledge. No information overload, just clear insights. Today, we're taking a fascinating deep dive into a compound that's been gaining a lot of buzz in the world of healthy aging, berberine. It's got a long, rich history, but modern science is now revealing some truly remarkable connections to how our bodies age at a fundamental level.
Yeah, what's truly fascinating here is observing how a compound rooted in, well, ancient tradition is now proving to influence the very biological pathways that dictate how we age. Our mission today is really to pull back the curtain on berberine, what it is, how it works at a cellular level, and critically, what that means for your longevity and healthy aging journey.
So let's unpack this and get right into it.
Hmm.
To kick us off, when we talk about berberine, my mind immediately goes to something maybe developed in a lab, but it's actually much older than that, right? What exactly is this compound?
That's a great starting point because you're absolutely right. It's far from a new synthetic discovery. Berberine is actually a naturally occurring chemical compound known as an isoquinoline alkaloid. Think of it as a bitter-tasting yellow pigment found in the roots, rhizomes, and stem bark of several plants. We're talking European barberry, golden seal, Oregon grape, philodendron, and even certain types of tree turmeric and a plant called Coptis chinensis. For centuries, it's been a staple in traditional Chinese medicine and Ayurvedic practices, primarily for issues like diarrhea.
Diarrhea. Interesting.
Right, which begs an interesting question. How does something used for gut ailments for millennia suddenly become, a hot topic in cutting-edge anti-aging research?
It's incredible, isn't it? It seems like traditional wisdom often holds keys that modern science eventually unlocks.
Yeah.
So if it's been around for so long, used for things like that, what was the aha moment, the connection to anti-aging? What's the bigger picture here?
Well, initially, modern research focused more on its metabolic effects, things like blood sugar regulation, which we'll definitely get into.
Okay.
But the real aha moment, I think, came as scientists started to understand the deep interconnected web of cellular processes that contribute to aging itself. We discovered that berberine isn't just like a surface level actor, it's influencing fundamental biological pathways that govern cellular health and ultimately lifespan. It's almost like finding that a simple traditional tool actually has a sort of master key to the body's entire aging operating system.
That's a powerful analogy. Now that we know what berberine is, the real intrigue comes when we understand how it works. Forget the broad strokes for a moment. Let's zoom right in, down to our cells.
What exactly is berberine doing at that fundamental microscopic level to literally extend life?
Right. If we connect this to the bigger picture, the research consistently shows that berberine does extend lifespan across various organisms, starting with simpler models. So, for example, in fruit flies, Drosophila melanogaster, it extended their viability and even their physical activity like climbing, which is a key marker of youthful function.
Even when stressed. Even when they were exposed to higher temperatures that normally accelerate aging, yeah. It also managed to put the brakes on something called mTOR6 signaling.
Ah, MTR, right.
Exactly, a major pathway involved in cellular growth and aging, and it significantly reduced harmful oxidants in their cells. What's more, in yeast, a very basic model of cellular life, a relatively low concentration of berberine extended their lifespan by an impressive 28%.
Wow, 28%. How?
It seems it achieved this by making their cell divisions more consistent and healthy rather than becoming irregular and prone to errors as they aged.
Okay, extending lifespan in simple organisms like yeast and fruit flies is one thing, and certainly compelling, but our bodies are vastly more complex. What about the intricate mechanisms of aging in mammals or even in us? Does the cellular benefit translate?
This is where it truly gets interesting for human health. Aging in mammals, it's characterized by this progressive loss of physiological integrity.
Things just start wearing out.
Basically, yeah, our body systems become less efficient, leading to impaired function and increased vulnerability to disease. And one of the most critical mechanisms involved here is cellular senescence.
The zombie cells, right?
Exactly, the zombie cells. Cells with irreparable damage that stop dividing but don't die. Instead, they hang around, releasing these inflammatory signals that harm healthy neighboring cells and restrict overall lifespan. Berberine has been shown to actually ameliorate or sort of improve cellular senescence and extend the lifespan of mice, specifically by regulating key proteins like P16 and cyclins.
So if I'm understanding this correctly, berberine is actually acting on the aging process of individual cells. That sounds almost too good to be true.
Yeah.
Is it preventing damage or helping repair? Or how does it slow down that cellular aging clock?
It's more about helping cells continue to divide healthily rather than hitting that senescent wall, that dead end. When we look at specific human cell models, like these human fetal lung fibroblast cells, which are common cells researchers use to study aging, even a very small amount of berberine promoted cell proliferation.
Keeping them going.
Exactly, effectively ameliorating that replicative cellular senescence. Essentially, it helps cells bypass the stop signal that typically tells them to age and stop dividing. It does this by decreasing the level of P16, which is a protein that acts like a brake on cell division,
Okay.
and by increasing cyclin D1 and CDK4 expression. These are proteins that act more like accelerators, promoting healthy cell cycles. It also upregulates something called phosphorylated retinoblastoma protein, or PRB, which is absolutely crucial for cells to progress through their normal division cycle.
Mhm.
It's like giving your cells a tiny internal youth boost by optimizing their natural division processes, helping them stay active and functional longer rather than just becoming senescent and worn out.
So it's not just slowing wear and tear, but actively helping cells maintain a more youthful function. That's fascinating. Given how critical cell health is, especially for our hardest working organs, it makes me wonder, does berberine extend this protective effect to specific organs, like, say, our heart?
That's a perceptive question, and yes, it absolutely does. The heart is under immense pressure, right? And its cells are particularly vulnerable to aging. Berberine exerts significant protective effects on cardiac injuries and critically on cardiac senescence, the aging of heart cells. Studies have clearly shown it protected heart cells from induced damage.
Like from toxins?
Yeah, like doxorubicin-induced senescence, but also in naturally aged rats, protecting them from cardiac aging. This involved lowering markers associated with an enlarged, struggling heart and, importantly, increasing the expression of an anti-aging protein called Klotho.
Klotho. Okay, that sounds like a key player. How does it tie into berberine's effects? Is it like a master switch for heart longevity?
Klotho is truly fascinating, often called the longevity protein. When researchers introduced external Klotho into cardiac cells, it produced effects strikingly similar to berberine.
Like what?
It reduced harmful reactive oxygen species, cellular rust. It inhibited apoptosis, which is programmed cell death.
Cell suicide, essentially.
Right. And it alleviated mitochondrial dysfunction, meaning it helped the cell's powerhouses work better. What's crucial here is that berberine significantly increased Klotho expression in these cells. And when Klotho was intentionally blocked or inhibited, berberine's protective effects were greatly reduced.
Ah, so it really needs Klotho to work its magic on the heart.
It strongly suggests berberine is working through Klotho, yeah. Additionally, berberine dramatically reversed the downregulation of another crucial anti-aging protein called SIRT1 or SIRT-T1 in the aged heart.
SIRT-T1, another familiar name in longevity.
Exactly. And both berberine and Klotho were shown to increase SIRT-T1 expression. So it seems like a synergistic effect. This suggests that berberine is protecting the heart from aging through multiple pathways, fighting oxidative damage, preventing premature cell death, improving mitochondrial function, potentially all converging through this vital Klotho-SIRT-T1 signaling pathway.
Wow.
It's essentially helping your heart cells maintain their energy and resilience against the wear and tear of time.
That's a pretty comprehensive protective package for the heart. So we're talking about cellular health, heart health, both absolutely foundational for longevity. But berberine is also, as you mentioned, often discussed for its profound impact on metabolism, right? How does that fit into this bigger picture of healthy aging? Because metabolic issues are such a pervasive challenge, especially as we get older.
It fits perfectly, really, because metabolic health is just inextricably linked to aging. Dysregulation of blood sugar and lipids contributes significantly to chronic diseases that definitely accelerate aging. Berberine emerges as a powerful natural tool for improving glucose and lipid metabolism. This offers potential applications for metabolic diseases like type 2 diabetes and dyslipidemia, which are indeed significant factors in aging populations.
Okay, how does it do that? What are the mechanisms?
Well, it's multifaceted. It can stimulate glucose uptake in cells, almost like opening more doors for sugar to leave your bloodstream and enter where it's needed.
Getting it out of the blood.
Right, it inhibits gluconeogenesis, which is your liver creating new sugar, so it reduces that output. It also increases the expression of insulin receptors on cells, making them more sensitive to insulin, and boosts GLP-1, a hormone that helps regulate blood sugar. Furthermore, it can suppress certain intestinal enzymes that break down sugars in your gut, which slows down sugar absorption. But perhaps its most significant mechanism, or one of them anyway, is activating AMPK.
AMPK, the energy sensor.
Exactly, a master switch for energy in your cells. It essentially tells your body to burn fuel more efficiently, improving mitochondrial health and overall energy homeostasis.
That sounds incredibly comprehensive. For someone listening who might be dealing with blood sugar concerns or maybe just thinking about long-term metabolic health, what stands out to you in terms of berberine's real-world impact? Like, does it actually move the needle?
Oh, absolutely. In clinical trials, berberine has shown a very clear hypoglycemic or blood sugar lowering effect in patients with newly diagnosed high blood sugar.
Oh.
We're talking about 0.5 grams taken twice a day, significantly reducing both fasting plasma glucose and 2-hour post-meal glucose compared to a placebo.
That's significant.
It is. It also has strong effects on HbA1c levels, which gives you that average readout of your blood sugar over a few months. Some of the sources we looked at even describe berberine as a heavy-hitting, potent tool for blood glucose regulation. Its effects have been shown to be quite similar in magnitude to prescription drugs like metformin in some studies.
Really? Comparable to metformin?
In some contexts, yes. It's not a subtle effect. It's a significant one.
And beyond just blood sugar, what about cholesterol? That's another major metabolic marker, very relevant to heart health and aging.
Yes, its benefits extend to lipids as well. Its hypolipidemic or cholesterol-lowering actions have been confirmed in human studies. These show a significant decrease in LDL-C, what's commonly referred to as the bad cholesterol, and a slight but positive increase in HDL-C, the good cholesterol. So it's not just tackling blood sugar, it's offering these comprehensive metabolic benefits that ripple out to improve overall health and potentially reduce age-related disease risk.
That really paints a picture of systemic metabolic improvement. And with so much focus on personalized health these days, this raises an important question. Does our gut microbiome play a role?
Yeah.
How does our gut interact with berberine?
That's a crucial layer to this puzzle, absolutely. Our gut microbiota, the trillions of microorganisms living inside us, actually plays an active role in how berberine is processed.
Oh, so.
Well, they can convert berberine into other metabolites, like dihydroberberine or DHBBR, using specific enzymes they possess. This conversion can significantly influence berberine's absorption and ultimately its therapeutic effectiveness in your body. It's not a one-way street, though. Berberine itself can regulate the gut microbiota, essentially shaping the ecosystem within your gut.
So it changes the gut bugs, too.
Exactly. This can lead to increased production of, in simpler terms, it's not easily absorbed. Your body doesn't absorb a lot of it directly into your bloodstream. And what does get absorbed undergoes extensive metabolism into over 20 different metabolites. So while it's generally considered much safer orally compared to, say, getting it intravenously where acute toxicity has been seen,
Right.
it's not simply absorbed fully and easily like some other compounds you might take. This is why formulations and maybe individual responses can vary quite a bit.
That's a crucial distinction.
Mm-hmm.
So it's potent, but its absorption is complex. What else should listeners be aware of if they're considering it for their own health journey? What are the cautions?
Well, due to its significant effects on blood sugar and also its potential impact on blood clotting, berberine can interact with certain medications. This is really important.
Okay.
For instance, if you're taking anti-diabetes drugs, combining them with berberine could potentially cause your blood sugar to drop too low, causing hypoglycemia.
Right, you don't want that.
Definitely not. Similarly, if you're on anticoagulant or antiplatelet drugs medications that thin your blood berberine might increase your risk of bruising and bleeding. It can also interact with certain antihypertensive drugs. This means closely monitoring your blood sugar is absolutely crucial if you take it, especially if you have diabetes. And most importantly, you should always consult your doctor before considering berberine.
Absolutely.
Especially if you have pre-existing conditions like diabetes or hypoglycemia, or if you're on any medications at all. And starting with the lowest possible effective dose is always recommended, under medical guidance, of course.
That direct, personalized advice is so critical, especially with something this impactful. Beyond the clinical trial data and the mechanisms, have you heard any interesting personal benefits people report, anecdotally from incorporating berberine?
Yeah, it's always interesting to hear the real-world experiences. Anecdotally, quite a few people report feeling fewer sugar cravings over time while taking berberine.
Oh, interesting. Like less desire for sweets.
Exactly, which suggests there might be some subtle neural effects at play, maybe regulating the circuits in our brain that drive those cravings. That would be a fascinating area for future research.
Yeah.
It's a common observation that aligns with its blood sugar balancing effects, obviously, but it points perhaps to a broader impact on how we interact with food.
What an incredible deep dive into berberine.
Yeah.
Seriously, from its ancient roots to its modern scientific validation, we've seen how this natural compound is really a multifaceted player in the game of healthy aging. It influences cellular senescence, helps protect our hearts, masterfully regulates our metabolism, all while interacting with our unique gut microbiome. It's quite something.
It really is, and knowledge is most valuable when understood and applied, right?
Yeah.
Understanding these fundamental mechanisms isn't just academic, it empowers you to make more informed decisions about supporting your own longevity and overall well-being. It highlights how connected all these systems truly are.
So, what does this all mean for you listening? It means the journey to healthy aging is continually revealing new insights, often from unexpected places like ancient plant remedies. Think about how many other traditional compounds might hold further keys to unlocking longevity benefits, just waiting for modern science to fully explore them. The future of healthy aging is likely to be this dynamic blend of deep wisdom and cutting-edge research, always evolving, always fascinating.